to start to review, I can tell you how many questions from each unit. Okay. Okay. Can you FOIL these two right here? FOIL them. Yeah. FOIL these two.
Where is it writing?
In the line. So then 2x times 3x. You can write it up here if you want. 6x squared plus 2x times 4. And 1 times 3x. 1 times 4. So what does that simplify to? 6x squared plus 11x plus 4. Okay, so that would mean that 6x squared plus 11x plus 4 factors to 2x plus 1 and 3x plus 4, right? Because what we're doing in factoring is we're working backwards from FOIL. We're taking the expansion and turning it into the product. So if this was the product that gave us this expansion, that expansion is equal to this product, basically. It's like Jeopardy. Now we know the question, what's the answer? Or no, now we know the answer, what's the question? That's what Jeopardy is. You have to watch more Jeopardy. Notice how these two first numbers, 2x and 3x, notice how, like if I wrote this way, 6x squared plus 11x plus 4, okay? Notice how the 2 and the 3, the first two, do they multiply to the 6? Yeah. Beside the 2, what should go right here? The 1 or the 4? Remember, each row is a factor. So if this is the 2x, this is the 3x, what would be right here? Plus 1, and this guy would be the plus 4. Do you see how 1 times 4 gives you this one here, just like before? 1 times 4. Right? Now, the diagonals. A little bit more complicated, but 2 times 4, what's 2 times 4? 8. 3 times 1, 3 gives you the 11, the middle term. Right? The product, notice the 8 and 3 came from when you're expanding it, those two, before you collected the like terms. That's where those are coming from. And so the product of the diagonal should add to the middle term still. 2 times 4 plus 3 times 1 gives you 11. And that's how we're going to factor. Did you already do this guy? No? Yes? Do we really need to? Let's move on. Do you want me to? Yeah, let's move on. Okay, so really briefly, algebra tiles, what is this expression? How many x squareds do I have? 2x squared, how many x's? 7 x's, you're right. 7x plus how many ones? 6. So if we had to draw that into a rectangle. So remember that at the top left corner goes your x squareds, right? So let's do them beside each other. You could either do top and bottom or right beside each other. It's hard to draw. So there's our 2x squareds, kind of. Not very squarish. So you have to somehow fit in 7 of these rectangles and 6 of the ones. So remember this, that the axes are going to go here and here. 1, 2, 3 spots. Okay. So how would we arrange that? So we have 6 ones. So for example, if we know the 6, well, there's different ways we can arrange it, but the ones are going to go down here. So if I want 1 there, that would mean you have to have an x here and 2 x's here, for example. Right? So that's 3 of them. I need 7. What else could I do? 2 more on the bottom. I'll put another one on the side. That would only be 2 ones. Where else could I put one? How would you arrange that? Any ideas? 3 beside them, like here. Okay, so 3 here. That's 5. And then
2 on the bottom.
2 more on the bottom. Would that work for our 6 ones? That would do it. Okay, so we'd have to form the rectangle. So you have to play around with it a little bit. It's a little bit more complex when you have more than one x squared. So what would be the dimensions up here? So x plus x is how many x's? So what's this dimension right here? The red. X?
2x plus 3.
So 2x plus 3. We have an x and an x and then 3 ones. So 2x plus 3. And what would be the dimensions? 2 or 1x?
1x plus 2.
1x plus 2. Okay, that would be an x plus 2 dimension. So it factors to 2x plus 3 times x plus 2. So if you, we have algebra tiles, if you ever want them to play with and do that for factoring, you're welcome to. Although we want to kind of get used to not working with the manipulatives as we move more into high school math, right? So that's factored form. So one would be your length, one would be your width. Right? Length and width. So let's not use algebra tiles though. And let's try factoring with this guess and check, or like the crisscross method. Okay? Okay, so we need 2 numbers that are going to multiply to 5. Has to be 1 and 5. It's prime, which is wonderful. I like prime numbers. Okay? 1 and 5 are 5 and 1. And then 2 numbers that multiply 2, 1 and 2 or 2 and 1. So this is where you're going to want to use a pencil, because there's 2 ways we can arrange it, and the diagonals will change based on where you put that 1 and 2 now. So if I put, for example, 1 here and 2 here, okay? What would the diagonals add to? The product of the diagonals? 11. 5 times 2 is 10. 1 times 1 is 1. That would add to 11. So will that work? No. So then let's switch the 2 and the 1. Do the diagonals now add to 7? When you add, yeah. 5 times 1, 5. 1 times 2, 2. So that adds to 7. Okay, so what would that turn into as factored form? Remember, each row is one of your factors.
Plus 2.
Careful, I left something out.
X.
The x's. So it'll be 5x plus 2 and 1x plus 1. Okay, everything was positive. So we're adding to a positive 7, multiplying to a positive 2, so they're all positives. And that's factored form. Yeah. When we're writing it?
Yeah, but like, no, in this question. On the other one, weren't we reading it like diagonally?
Nope. So each row is always a factor. But we were using the diagonals to just make sure it equals the middle term. It just happened to be that when it's simple, these 2 numbers multiply to this and add to the middle. But that's not the case anymore when it's complex. Okay? Now we're not going to factor by grouping. So we can skip all of this. We're just going to keep the same method every time. We're also not factoring by decomp, which used to be how I used to teach this. You're more likely to make a mistake. Okay. So let's just go through. Ignore. So in the homework, if they ask you to factor by decomposition or factor by grouping, just ignore it. Okay. We'll just go ahead and factor the way we normally. If we stick to the same method every time, it's nice to be consistent, right? Instead of learning all these different methods. Okay, so multiplying to 2. Is there a GCF here, by the way? 2x squared, 7x, and 6. No. So 2 numbers that multiply to 2. 2 and 1. That one's easy. Okay, now we have a few options with 6. Because all the factors of 6, we can either go 1 times 6 and 2 times 3, right? So we want to make diagonals we multiply the diagonals, they're going to add to 7. 2 and 3. Okay? So where would I put the 2? Like here? Okay, let's check that. 2 times 3. 6. 1 times 2. Does that add to 7? No. So should we try switching them? Instead, let's put 3 on top and 2 on the bottom. Does that work? 2 times 2? 4. 1 times 3? 3. That will equal 7. Yay! Okay, what am I missing? The x's and the signs. So it turns into 2x plus 3 times x plus 2. You ready to try be on your own? Okay, give it a shot. There is a little bit of a guess and check, right, in this. You are playing with it a bit, but I assure you it's so much faster than decomposition. 5 times 1, only way to multiply to 2. 2 and 1, we want to make 7. So beside the 5, what goes there? The 2 and the 1 goes on the bottom. That should work. 5 times 1 is 5. 1 times 2 is 2. That makes 7. So you should have had 5x plus 2, x plus 1. Good? Great. I think it's going to be a short lesson. That's fun to practice. Maybe hand back some tests today. Your trigonometry test you haven't seen? Right?
Oh,
It's been so long, you probably forgot about it.
no,
Oh.
And the test it out today, like
Oh. Haha, no. We're not ready yet. Okay, 6x squared. We want to multiply to 6. Now this is a tough one because it's a complex trinomial. First of all, is there a GCF? You should always check if A is not 1 if there's a GCF. 6, 17, and 3. No, 17 and 3 are both prime. No GCF. Okay, so now we have 2 options for 6, right? Because it either could be 2 times 3 or 6 times 1. Where do you want to try first? Okay, let's try 2 times 3. Now the nice thing about 3 is it's prime. So, Karen, can you put that on my desk, please? Every day. Shouldn't have to be asked. Thank you. Okay, so if I put the 3 up here, now we know that 1 has to be positive and 1 has to be negative because the sign is negative here, right? We have a negative product. So 1 positive, 1 negative. We know that's going to happen. Let me zoom in. Sorry, should have done this earlier. Okay, look how big it is now. Oh, nice and big. Okay, so if I did this, okay, first of all, let's just try this. And then we can see if we can make it 17 somehow. 2 times 1 is 2, 3 times 3 is 9. Is there any way, if 1 was positive, 1 was negative, to make 17? No. Okay, so if I switch the 3 and 1, so I'm now going to put 1 and 3 here. I get 6 and 2. 2 times 3, 3 times 1. Oh, sorry, 6 and 3. Any way to make 17 that way? No. So guess who we need to change? 6. So it's not going to be 2 and 3. We need to try 6 and 1. So we'll play with the signs later, but let's leave this the way it is now. 6 times 3 gives you 18. 1 times 1, 1. Is there a way to make 17 out of this? Negative 1. If the 1 was negative, that would do it for us. That would also make our negative 3, which is what we need. So the factored form would be each row, right? 6x minus 1 and x plus 3. Want to try B? Okay, you try. So it's in the wrong order. So let's rewrite it in the proper order. Negative 2y squared, then negative 7y, and plus 15. Now here's the thing. If your a value is negative, you want to GCF the negative out. Okay? So if a is less than 0 or negative, a is less than 0 or it's a negative, GCF negative 1. We're going to make GCF, it's going to be negative 1. We want to take the negative out of everything. We want to get rid of the negative. It's just more of a pain than is helpful. So what I mean by that is if I GCF of negative 1, I factor out a negative, what happens to all my signs? They all change. So the negative becomes a positive, minus 7y becomes plus, and plus 15 becomes negative 15. Okay? Now, is that what you're used to seeing? Yes, so that's what we want to factor now. Okay? Always take the negative out. This will be useful not just in factoring in grade 10, but in grade 11 and in grade 12. Okay, take that negative out. So now factor that. Two numbers to multiply to 2. 2 and 1. Okay, now we want to make 7. And our product is negative 15. So 1 positive, 1 negative number. 3 and 5. I'm going to try those. Okay, so if I put 5 here and 3 here, sometimes you get lucky, sometimes you don't. Did I get lucky? No. 6 and 5, you can't make 7 out of 6 and 5. Doesn't matter who you make negative. So then I'll try switching them. 3 and 5, will that work? Yes, because that gives me 10. And 1 times 3 is 3. How do I make positive 7 out of that? Negative 3 would do it. So negative 3. Y and y would go here. So factored form, what do I need to remember? The negative in front, 2y minus 3, and y plus 5. I mean, obviously, if there's a GCF larger, like if this was like, say, 8 and a 16, I would GCF negative 2f. I pull out the negative plus the number that's a GCF as well. But here it was just, there was no other GCF, like just negative 1. Okay. This guy, does he have a GCF? Yeah, we can divide them all by 5, and we're left with 3k squared plus just k minus 2. Okay, so go ahead and factor that. Not many options here. Okay, dividing each by 5. How do you know? K is just a variable like x. So we can use anything. So we, oh, 1. Oh, K. Oh, I get it now. Yeah, the coefficient's 1. If you don't see the coefficient, it's a 1. Oh, no? Or you just mean in general what's K? Oh. I don't think it's good. Where does the 1 and where does the 2 go? No, that won't work. 3 and 2, I want to make a positive 1. So negative 2, positive 3, that would make a positive 1. So that factors 2. 3k minus 2 is k and k. K plus 1. And don't forget, what am I missing? Landon, what am I missing? Landon, what am I missing? Five, your GCF. Okay, don't forget to put that in front, else you'll lose marks. And it's just a stupid mistake that's made. That's all that is. It happens because you just are rushing and you get excited because you found your factors and you forget about the GCF. So one more type of question. This is a special type of trinomial that has two squares in it. Okay, an x squared and a y squared. But that's okay. It's still in the proper form. I'm going to show you how to factor this. We're going to treat the numbers the same. Just ignore the variables right now. Let's just work with the numbers the way we're used to. So two numbers that multiply to 2. 1 and 2. We want to make the sum of -5. Okay, but a product last is 2. The diagonals need to... So what are the numbers going to have to be? 1 and 2. So I'm going to put 1 and 2 here. Why did I put 1 and 2 there? 2 times 2 will give you 4, and 1 times 1? 1. So I want to make this a -5. How could I make that a -5? If they're both negative. So -1 and -2. And if I double check, will that give me still my product of a positive 2y? Yeah. So now we need to put our variables in. So here, if I wanted to actually make a product of x squared, it's actually 2x and 1x. Okay. And then over here, I want to make the product to be actually positive 2y squared. Y and y. 1y and, whoops, I didn't want that to move. -1y and -2y. Okay. And so the reason, and that would still give me my middle term of -5xy, because when you actually multiply 2x by -2y, it's actually -4xy. And when you multiply 1x times a -y, it's -1xy, which makes -5xy's. Okay, so that's the middle term of the FOIL, because there's an x times a y and an x times a y. Then we add them together. So that would be the factored form of 2x minus 1y, or 2x minus y, and then x minus 2y. So work with your numbers first, then throw your variables in. Okay? I think we're done. Yeah, let's skip B. Yeah? Okay. So the assignment is, you ready to highlight? I'm going to zoom out. Highlighter. So today we're on lesson 6. Okay, skip number 1 on the page. You do not need to do algebra tiles if you don't want to. You can just factor, okay? Just good old same method every time if you want. So 2 to 4 ACE, 2 AC, 3 AC, E, and 4 ACE. You don't have to do 5. 6 is ACE. And again, I think it might have said decomposition at one of them. Did it?
No.
No? Oh, good. You're good. Okay, good. Okay, and then all the way over to 10, 9, 10, 10, 12, and 13. 10, 12, 13. Ready? And then your workbook, your little handout. Handout, or, I don't know. What did I just spell? I was trying to, my brain was doing workbook and handout in one, and I got handout. Page 41. No, page 41. Yeah. Well, yeah. How much is on page 41 then? How many?
That's what I was asking. I was like,
It's really good practice. Anyone still need the handout? Okay, come grab it. Let's just go evens for now. Okay, page 41, evens. However, that's the bare minimum. The more you practice your factoring, the faster and the better you'll be. Okay. Sounds good? So that's 10 questions instead of 20 on there. Still need a midterm review booklet. They're in the bucket on the bulletin board. without. You'll have to remember this later. So for example, if I didn't take the GCF in this one, I could have done 3 and 1. Say I forgot. Okay. And then I could have done so 15 and 4. Multiply to 60, right? And then we want to make this is 12 and 15. So negative 15 would make this a negative 3. Okay. So then this would have factored to 3x minus 15 and x plus 4. But then I notice I can divide both of those by 3. So if you forget to GCF in the beginning, you're going to have to notice it at the end. So I can divide both of these by 3. So I factor the 3 out to get x minus 5. Okay? So you should be able to notice it at the end too.
I need to go to the bathroom. Or, I can keep my like I'm actually
He's already done with everything.
oh my god.
She quits.